Hi, welcome back. In this video, we're going to do a few examples from the recent worksheet. We're going to do some substitution examples. So in the first example, number 3, part A, we've got the indefinite integral of 5 to the x times sine of 5 to the x dx. So remember, when you need to do a substitution, you're looking for a composite function in your integrand, and your substitution, your u, is going to be the inside of a composite function. So looking at this integrand, I see I have a sine of 5 to the x, so that's a composite, and the inside is 5 to the x, so I'm going to try u equals 5 to the x. So I write down my substitution, and then underneath I'm going to find my differential du. So the differential du is the derivative of 5 to the x, so that's 5 to the x times natural log of 5 times the differential dx. And then we look back at the integral and we look and see if we have a 5 to the x times natural log of 5 times dx, and we see we have the 5 to the x times dx, but we don't have a natural log of 5. But that's okay, it's just a number, it doesn't have an x in it. So we go back to our equation, our differential, and we just divide both sides of the equation by the natural log of 5. So we get 1 over natural log of 5 times du is equal to 5 to the x times dx. And now we can get rid of all the x's and dx's in our integral and just be left with u's and du's. So let's go back and make the substitution. So we get the indefinite integral of sine of u times the 1 over the natural log of 5 times du. And now 1 over natural log of 5 is just a constant that can be pulled out of the integral. So we have 1 over natural log of 5 times the indefinite integral of sine of u du. And so we just need the antiderivative of sine of u. So we get 1 over natural log of 5 times the antiderivative of sine of u, which is negative cosine of u, plus an arbitrary constant c. Remember, indefinite integrals, you always end up with a plus c. All right, we're not quite finished. Notice we have a function of u, and we need to have a function of x. But all we have to do is resubstitute. Remember, u is just 5 to the x. So we can rewrite our answer as negative 1 over natural log of 5 times cosine of 5 to the x plus c. All right, let's look at part B. Part B, we have the indefinite integral of sine of x times sine of cosine of x dx. So I see the composite sine of cosine x, so I'm going to try my substitution u equals the inside function, cosine of x. So we write down the substitution, u equals cosine of x. Then we write down du, the differential. It's the derivative of cosine x, which is negative sine x, times the differential dx. And then looking back at the integral, we see we do have a sine of x dx, but it's positive. That's okay, we can deal with that. We go back to our differential equation and we just multiply both sides by negative 1. We get negative du is equal to positive sine x dx. And now we can make our substitution. So after we substitute, we get the indefinite integral of sine of u times negative du. And we can pull that minus sign out or just leave it. So we're looking for the antiderivative of negative sine u, and we know what that is. We know that's the cosine of u, because the derivative of cosine is negative sine. All right, so we have the antiderivative cosine of u plus c, but we have to go back to x. So we replace u with cosine of x. So we have cosine of x plus c. All right, let's look at some more examples. Let's do some definite integrals. In this example, we've got the definite integral from 0 to 1 of dx over 1 plus the square root of x raised to the 4th. So I do have several choices for my inside function. I'm looking for a composite function, and I'm going to let u be the inside of a composite. So I have a reciprocal function. I have 1 over something to the 4th. So I could let my u be the entire denominator, 1 plus square root of x raised to the 4th. I also have a power function, 1 plus square root of x raised to the 4th. So I could let my inside be 1 plus square root of x. Try something. If it doesn't work, try something else. So what I'm going to try is I'm going to try u equals 1 plus square root of x. So now what I have to do is find the differential and see if I can get rid of all my x's and dx's. So the differential du is going to be 1 over 2 times the square root of x times dx. Now, I don't have a 1 over 2 square root of x. I do have a dx. So what happens if I multiply both sides of this equation by 2 times square root of x? I get 2 times square root of x times du is equal to dx. Now, I can't use that. I can't replace dx with 2 square root of x du because I've got an x and a u. I have to get rid of all of my x's. I can't mix my variables. So what am I going to do about that square root of x? I have to figure out a way to get it in terms of u so I can get rid of it. If I go back up to my first equation, u equals 1 plus square root of x, I see, oh, I can subtract 1 from both sides, and I get u minus 1 is equal to square root of x. So let's see what happens if we replace that square root of x in the differential with a u minus 1. So I have 2 times u minus 1 du is equal to dx. All right, so let's try it and see what we get. Before we do make the substitution, though, we have to replace our limits of integration. So when x is equal to 0, u is 1 plus the square root of 0, so u is 1. When x is 1, the upper limit of integration, u is 1 plus the square root of 1, so that's going to be 2. So now let's put everything in and see what we get. So we get the definite integral from 1 to 2 of, and now dx is going to be replaced with 2 times u minus 1 du, and then the denominator, 1 plus square root of x to the 4th, that's replaced with u to the 4th. So let's first pull out the 2, and then we have a u minus 1 over u to the 4th. I can break that up. I can call that u over u to the 4th minus 1 over u to the 4th du. And now, simplifying a little bit and rewriting using exponents, I get 2 times the definite integral from 1 to 2 of u to the negative 3 minus u to the negative 4 times du. And now we know how to use the power rule on that, or the anti-power rule. So now we get 2 times the antiderivative, which is u to the negative 2 over negative 2, minus u to the negative 3 over negative 3. And we have to evaluate that from 1 to 2. All right, so plugging in 2, I'm going to have 2 times negative 1/8 plus 1/24, 1 over 24. And then plugging in 1, I'm going to get minus 1/2 plus 1/3. All right, so adding together all my fractions, multiplying by 2, my final answer is 1 over 6. All right, so I picked a substitution that at first looked like it wasn't going to work, but I was able to rewrite part of my differential. My differential dx turned out to be a mixture of x's and du's. It was 2 square root of x du. I had to get rid of that square root of x, but I was able to rewrite it using my original equation for u. All right, let's look at one more definite integral. In this one, we're integrating from 0 to pi over 3 sine of x minus cosine of x over sine of x plus cosine of x dx. So I do have a composite. I have a quotient where I have two inside functions. I have sine of x minus cosine of x and a sine of x plus cosine of x. But I also have a reciprocal function, 1 over sine of x plus cosine of x. So I'm going to try that substitution where the inside function is the denominator, sine of x plus cosine of x. The reason I'm choosing that is because in my head, when I differentiate that, I see I'm going to get the numerator or something very close to the numerator. So my differential might actually work. So let's see what the differential is. du is going to be the derivative of sine x, which is cosine x, plus the derivative of cosine x, which is minus sine x, times dx. And I look back at my numerator, and my numerator is sine of x minus cosine of x times dx. That's pretty close. All I have to do is multiply by -1 to get that. So negative du turns out to be the opposite of cosine x minus sine x, which is sine of x minus cosine of x dx. All right, so I can make the substitution, get rid of all my x's and dx's, but now I have to also change my limits of integration. So when x is the lower limit, 0, u is going to be the sine of 0 plus the cosine of 0. So it's u plus 1, which is 1. My upper limit, when x is pi over 3, u is going to be the sine of pi over 3, which is root 3 over 2, minus or plus the cosine of pi over 3, which is 1/2. All right, and I can simplify that a little bit. I can call that root 3 plus 1 over 2. So making the substitution, we get the definite integral from 1 to root 3 plus 1 over 2 of negative du over u. So pulling out the minus sign, I can call that the definite integral from 1 to root 3 plus 1 over 2 of 1 over u du. And we know the antiderivative of 1 over u is the natural log of the absolute value of u. So we get negative natural log of the absolute value of u, and we have to evaluate that from 1 to square root of 3 plus 1 over 2. So when we plug in, we know the natural log of 1 is just 0. So we get negative natural log of square root of 3 plus 1 over 2. And if we don't like that minus sign, we can call it positive natural log of 2 over square root of 3 plus 1. All right. When choosing a substitution, you're looking for an inside function inside of a composite where the derivative of the inside is also someplace nearby. All right, I'll see you in some other videos.